This is Dr. Hayek, and this video is about UV visible spectrophotometry. In today's video, I'm going to discuss the Beer-Lambert's law. Let's start this video by defining spectroscopy, which is the study of electromagnetic radiation emitted or absorbed by a chemical species. The instrument that uses spectroscopy is called spectrophotometer. The spectrophotometer is an instrument that measures the amount of light absorbed by a substance. The spectrophotometer is made from a light source, a monochromator, a cuvette that's going to contain the sample, a detector that's connected to a computer that will analyze the data. Now the light source will emit a light with a range of wavelength between 400 and 700 nanometer. The light will enter the monochromator and will exit with a single wavelength with an intensity I0. Now some of the light will be absorbed by the sample and the light will exit with an intensity I. The light will hit later on the detector, which will analyze the data and send it to the computer, and we will see on the computer screen the absorption spectrum as it's illustrated in here. Now things to take into consideration when we do this measurement is the length of the cuvette. So L is the distance of the light travels through the solution. And also I0, which is the intensity of the incident light before hitting the sample. And finally I, which is the intensity of the light after it has passed through the sample. Now how can we use I0 and I? Now the transmittance T is a measure of the fraction of light that passes through the sample. It's the ratio between I and I0. So T is equal to I divided by I0. The percentage transmittance, %T, could also be used, and note that %T is equal to T multiplied by 100. The absorbance A is the amount of light absorbed by the sample. Now A is given by minus log base of 10 of T, which means it's equal to minus log of I divided by I0. The absorbance can also be given in terms of the percentage transmittance. A equals to 2 minus log %T. Now we can obtain this expression by working out the expression of A equals minus log of T and T equals to %T divided by 100. Now another interesting term to define is the absorption spectrum, which is the plot of the absorbance versus the wavelength of the light intensity. Now what we can take from the absorption spectrum is the maximum wavelength where the chemical species absorbs the maximum light. Now this means that for the lambda max corresponds the A max, which is the maximum absorbance. Now in a similar way, we can define the transmittance spectrum, which is the plot of the transmittance or %T versus the wavelength of the incident light. Now let's define the Beer-Lambert's law. The absorbance can be expressed by Beer-Lambert's law as follows. A equals to epsilon multiplied by L multiplied by C, where A is the absorbance of the solution, and there's no unit for A. Epsilon is the molar absorptivity or the molar extinction coefficient, and it's measured in liter per mole centimeter. L is the distance the light travels through the solution and is measured in centimeter, and C is the concentration of the absorbing species and it's measured in mole per liter. Now let's practice Beer-Lambert law. Suppose we have a pink solution containing an unknown concentration of cobalt-2 aqueous solution. A sample of this solution is placed in a spectrophotometer and the absorbance is measured at a wavelength where epsilon for cobalt-2 is known to be 12 liter per mole centimeter. The absorbance A is found to be 0.060. The width of the sample tube is 1 centimeter. The question is, determine the concentration of the cobalt-2 ion in the solution. Now in order to do so, since cobalt-2 is the only absorbing species in solution, so we can use Beer-Lambert law. Now, since we know the absorbance epsilon and L, so we can find C. C is equal to absorbance divided by epsilon L. Replacing each term by its value and cancelling the units, we get that the concentration is equal to 5.0 times 10 to the power minus 2 mole per liter. Now, another practical aspect of the Beer-Lambert law is the fact that the expression of the Beer-Lambert law is similar to the mathematical expression y equals ax, where a corresponds to y, epsilon L corresponds to a, and c corresponds to x. Now, this way, we can plot the absorbance versus the concentration, which is going to be a straight line that passes by 0. Now, if we find the slope of this plot using delta A divided by delta C, we get epsilon times L. So how can we benefit from this experimentally? Let's say we need to determine the molar absorptivity of KMnO4 solution. So we will start by measuring the absorbance values of at least 4 solutions with known KMnO4 concentrations to obtain the following data. So here we have the concentration and the absorbance. As you can see from the data in the table, when the concentration increases, the absorbance will increase as well. Now, on a graph, we can plot these points, the absorbance versus the concentration. Now, take the best fitting line of this point that passes by 0. Find the slope of this line by saying slope is equal to delta A divided by delta C. This slope is equal to epsilon multiplied by L, where L is the distance traveled by light through the sample, and it's usually the width of the cuvette, which comes around 1 centimeter. So we know L, we know the slope, we can find the molar absorptivity. I hope this video was helpful to you, so please like, share, and subscribe, and I'll see you next time.